In this video, I want to take a look at the integral of secant to the n x dx and develop the telescoping integral for this. I'm going to do it first for a small value of n. I'm going to do it for n equals 3, and then we'll come back to do it in general here. We're going to do this. There's two stages in this. There's a integration by parts, and there's a trig identity, which converts sines secants back into tangents, or vice versa. And it turns out you can do this integral with either step first. I think what I want to do is I want to do the integration by parts first. So I want to do u du v dv. And I'm going to break the secant cubed up into putting a secant squared x right there and just a secant x right here. So the u is secant x. It leaves secant squared x left over there, and it puts it here. The thing I like about this is the secant squared x is definitely something I know how to integrate. That's just tangent x. Right. Take the derivative of secant x, you get secant x tan x dx. So then, integration by parts, I started with u dv. So this is equal to u times v, secant x tan x, minus the integral of v du. So that's minus the integral of secant x tan x, and then I got another tan x, so why don't I make that tangent squared x, then dx. Okay. So what I do now is I'm going to do a trig identity here where the tangent squared of x is the secant squared of x minus 1. So I've got the secant x there, and then I've got a secant squared x minus 1 dx. And when I distribute the secant x in there, I've got a secant x tangent x minus the integral of secant cubed x minus secant x dx. So you see I'm back here to the integral of secant cubed that I started with. So I'm going to get some things together here. So this is the integral of secant cubed x dx is equal to all this stuff. So if I add this over to the other side, I've got 2 times the integral of secant cubed x dx equals secant x tan x. And so what I haven't done yet is I haven't integrated this part. So this integral actually breaks up into 2. There's this integral of this one and the integral of that one. And the minus minus is going to become a plus. Okay. So dividing both sides by 2 now, I've got the integral of the secant cubed x dx is 1/2 secant x tan x plus 1/2 the integral of secant x dx. So the secant cubed turns into something plus an integral of secant to the first power. Right? So we started with the secant integral of secant cubed, we ended with an integral of secant, which we happen to be able to do. Right? That's that goofy one. Natural log of the absolute value of the secant x plus the tangent x. Okay. Plus a constant. So that's secant cubed. For secant to the n, it's going to be a very similar thing, but I wanted to do this with actual numbers in here, so you can see how it's going to work. Right? So let's do this again now, but let's do it with secant to an arbitrary n power. Right? The integral of secant to the n x dx. I'm going to do this by parts, just like I did before. U du v dv. And what I'm going to do is I'm going to just put a secant squared x here, dx, because that's something I can integrate easily. So with the secant squared x dx being the dv, everything else has to go into u. So that would be a secant to the, we use 2 of them over here, so that must be n minus 2 factors left. Right. Take the derivative of this thing now. So this is secant of x raised to the n minus 2 power. So I've got n minus 2. I'm not going to have left myself enough room. I'm going to stick this down a little bit lower here. N minus 2 times secant to the n minus 3 power x times the derivative of what's inside, which is a secant of x. So the derivative of that is secant x tan x dx. These two are going to get together to be, I got secant to the n minus 3 times secant of x, so that's just secant to the n minus 2x times tangent x dx. So, I started with u and dv, so I end up with u times v. Whoops, I never figured out what v is, right? But that's just the integral of secant x, which is tan x. So u times v is secant to the n minus 2 power of x times the tangent of x minus the integral of v du. So minus the integral of, I'm going to leave a little bit out in front because this constant can just come out. That's an n minus 2 out here. And what do I've got? I've got a secant to the n minus 2x. I've got a tangent of x dx, but I'm also got another tangent of x. So from the du I've got a tangent x. From the v I've got a tangent x. So I'm at a tangent squared x dx. Okay, and then that tangent squared x, I'm going to, just like I did before, what did I do before? Where was it? I had a tangent squared x up here, and I turned it into secant squared x, right, minus 1. That's what I'm going to do again. So I've got secant to the n minus 2x tangent x minus n minus 2 times the integral of the secant, SEC, to the n minus 2 of x, and then the tangent squared of x turns into a secant squared x minus 1 dx. Distributing that through, I'm going to have an n minus 2 power and a 2 power, so that's going to just end up being an n power. So the original integral that I started with, right, it's this one right here, the integral of secant to the nx dx is equal to this first part, secant to the n minus 2x tan x minus n minus 2 times the integral of secant to the nx, because that's this times that, and the n minus 2 plus 2 is just n, minus secant to the n minus 2x dx. So I distributed this secant in through there. Now you can see I'm going to have an integral of the secant of x again, but I've got a minus n minus 2 of them over there. So I'm going to, well, let's take 2 steps here. So I've got the integral of the secant nx dx equals secant to the n minus 2x tan x minus n minus 2 times the integral of secant to the nx, x is down here, dx, plus n minus 2 times the integral of secant to the n minus 2x dx. So now I'm going to get this together with that. So I'm going to add n minus 2 of these things over to that side. So there's 1 over here already. I've got 1, and I'm going to add on n minus 2. So that is a total of n minus 1 of them. So I'm going to have n minus 1 times the integral of secant to the nx dx is equal to this stuff, secant to the n minus 2x tan x. This one over to the other side, so what's left here is plus n minus 2 times the integral of secant to the n minus 2x dx. Then divide by the n minus 1, so I've got the integral of secant to the nx dx equals 1 over n minus 1 times the secant to the n minus 2x tan x plus, I'm still dividing by the n minus 1 into this term now, n minus 2 over n minus 1 times the integral of the secant to the n minus 2x dx. And so our secant, integral of secant to the n turns into something plus an integral of secant to the n minus 2. Okay? So if you started off with a secant to the 7th, you'd end up with a secant to the 5th. You could then do it again to turn that secant to the 5th into a secant cubed. Do it again, turn the secant cubed into just a secant, and hey, we know how to integrate the secant. Anyway, there you go. There's your telescoping integral for secant raised to a power.